Today we're going to talk about applications of trigonometric functions. So these are some strategies for solving applications. We want to first translate all the key pieces of information from the problem, draw a sketch with all key points identified, develop an equation that models the problem, and of course answer the question or questions that are being asked. So for the first problem, it says a carnival Ferris wheel with a radius of 14 meters makes one complete revolution every 16 seconds. The bottom of the wheel is 1.5 meters above ground. So let's go ahead and start to kind of visualize what this looks like. So here's my Ferris wheel, and it says that the radius of the wheel is 14 meters, and it also tells us that the bottom of the wheel is 1.5 meters above ground. It says if a person at the top of the, or if a person is at the top of the wheel when the watch is started, so that means we're going to be here when we start. Determine how high above the ground the person will be after 1 minute and 7 seconds. All right, so let's go ahead and look at what information we need to write our equation. So remember, in order to write our equation, we have y equals a times sine or cosine, so we have to determine which one it is. So we're going to use sine of bx plus d, or y equals a times the cosine of bx plus d. So that means we have to figure out what our a, b, and d values are. So we know how to do this because we can find those values, a and d, our amplitude and our midline, using our maximum and our minimum values. So given the fact that we know the radius of the wheel is 14 meters, and we are 1.5 above ground, that tells us that the highest point here would be 14 plus 1.5, which is 29.5 meters above the ground. So the maximum is 29.5, and we know the minimum is 1.5. It told us that in the problem. So now we can find our amplitude. So remember, the amplitude is going to be the maximum, 29.5, minus the minimum, 1.5, divided by 2. So when we do that, we get an amplitude of 14, which of course makes sense because remember, we did our Ferris wheel problem before. We said the amplitude was the radius of the wheel. So it makes sense that we got 14 there. Then your midline is the average. So 29.5 plus 1.5, maximum plus the minimum, divided by 2, which gives us 15.5. And so that actually, remembers from the ground to the center of your wheel, so from here to here, that tells us that distance is 15.5 if we think about our Ferris wheel problem from before. So with this information, it usually helps if I start to think about a graph for this problem. And so in order to figure out the graph part, we want to also figure out the period and the key points. So it tells us in the problem that it makes one complete revolution every 16 seconds. So that means that the period is 16 seconds because that's what it takes to go all the way around the circle. So remember that the key points are going to be the period divided into 4 equal parts. So 16 divided by 4 tells us that our key points are going by intervals of 4 on our graph. So on my graph, I'm going to count by 4s. So 4, another 4 would be 8, 12, 16. And then I know that the minimum of my graph is 1.5 meters. And then the midline is at 15.5 meters, and the maximum is at 29.5. So remember, this is in meters. It's the height off the ground. And this is, of course, the time in seconds. And I'm going to also draw a dotted line for our midline. All right, so for our problem, the other key piece of information says that if a person is at the top of the wheel when the stopwatch is started, so that means we're going to be starting at 29.5. Determine how high above the ground we are after 1 minute and 7 seconds. So if we're at the top of the wheel and our Ferris wheel, if we keep going for the time, it's going to go down to this point next, because remember, we get divided into 4 equal parts. So here, here, down here, and here. So that means the next point we're going to be hitting is at 4 seconds, we're at the midline. At 8 seconds, we're at 1.5 meters off the ground. At 12 seconds, that means we would be here back at the midline at 15.5 feet off the ground, and at 16 seconds, we would be back at the maximum. So this gives us our rotation. And that's what one wavelength of our graph would look like. So we still need to find our b value. So remember that b times the period equals 2 pi. So that means that b is equal to 2 pi divided by the period, which is 2 pi divided by 16, which gives us pi over 8. So now remember, to write our equation, we need the amplitude, the midline, and our b value, which we have, and we can use our graph to help us. So the graph on the y-axis does not start in the midline, it starts above, so that tells us we're using a cosine equation. So for my equation, we get y is equal to the amplitude, which is 14, times the cosine of my b value, pi over 8 times x. And then we have plus our midline, which is 15.5. So this is my equation that I am going to be using. So now we want to answer, what is the height after 1 minute and 7 seconds? So remember that our equation's using x as time in seconds. So that means I know 1 minute is 60 seconds plus 7 gives us 67 seconds. So when x is 67 seconds, we're trying to figure out what our height is. So that means y is equal to 14 times the cosine of pi over 8 times 67 plus 15.5. And of course, we are using radian mode, because in our equation, when we were solving for our b value, we're using 2 pi in order to solve. So that's how we know we're in radian mode. And in my calculator, make sure I'm in radian mode, I go to mode. If you're not, you can just scroll down and then hit enter on radian. So now on my home screen, I'm going to go ahead and write my equation, 14 times the cosine. And then I would do a parenthesis, because right here, I would add a parenthesis because that's a fraction. Or you can just do 67 pi over 8, but I'm just going to do the double parentheses. So pi divided by 8 times 67, and then plus 15.5. So that gives us a y value of 20.86 when we round. And of course, remember that's meters, because that's how far above the ground we are. So our height after 1 minute and 7 seconds is 20.86 meters above the ground. And now we've answered the question. So for the next one, why don't you see if you can pause the video and read through the problem and answer it on your own, and then when you're done, unpause and we'll go through it. So for question 2, it says alternating half-day cycles of the rise and fall of the ocean are called tides. Tides in one section of the Bay of Fundy cause the water level to rise 6.5 meters above the mean sea level and to drop 6.5 meters below. The tide completes one cycle every 12 hours. Assuming the height of the water with respect to the mean sea level can be modeled by a sine function, graph and write the equation to model this situation. So if we are 6.5 meters above sea level, that's telling us that's our maximum. And 6.5 meters below sea level is going to be our minimum. And of course, the sea level is going to be at our x-axis. So right there would be the sea level. So your amplitude, of course, is the maximum minus the minimum divided by 2. So that gives us, of course, an amplitude of 6.5. And the midline is the maximum minus plus the minimum. It's average divided by 2, which gives me 0 over 2, which is 0, which is why our sea level is right here on the x-axis at y equals 0. And then it told us it completes one cycle every 12 hours. That means the period is 12 hours. And so the period divided by 4 is 3. So that means that 3 hours are our key points. So we have 3, 6, 9, 12. So that would be my key points on my graph, because remember the 5 key points. So if we start at 0, that's 1, 2, 3, 4, 5. And so then for my b value, we know that b times the period equals 2 pi. So that means b equals 2 pi divided by the period. So in this case, 2 pi divided by 12 is pi over 6. So for this, again, the maximum is at 6.5 and the minimum is at negative 6.5. So now we have to figure out where we're starting on our graph. So for this, it says tides in the section of the bay cause the water level to rise 6.5 meters above sea level and then drop. So it completes one cycle every 12 hours, assuming the height of the water respecting mean sea level model a sine function. So we're modeling this using a sine function. We want the equation to write the equation for this. So first, what did it do? It caused water to rise 6.5 meters above the sea level. So we're going to start here on the y-axis on the midline, because that's a sine graph, and then we're going to go up 6.5 because we're going to rise above sea level, and then it's going to go back to the midline, and then below the midline or sea level, and back to sea level. So this would be our sine equation. So we have y equals a times the sine of bx plus d. So now all I have to do is write the equation. So y is equal to 6.5 times the sine of pi over 6x. And my midline is 0, so I don't need to write plus 0. So that would be my equation answer. And that's all for this problem. So same thing with number 3. See if you can pause the video and do this on your own. When you're done, you can unpause to check your work. So for question number 3, it says Marcia is pushing her brother, Bobby, on a rope swing over a river. When she starts the swing, he is 7 feet over land away from the edge of the river bank. And then it says, after 2 seconds, Bobby is 11 feet over the water past the edge of the riverbank, assuming that the distance from the edge of the creek varies sinusoidally with time, and the distance y is positive when Bobby is over the water and is negative when he's over land. Write a trigonometric function that models the distance Bobby is from the edge of the riverbank at time x seconds. All right, so for a problem over the land, so remember in the problem it says when she starts the swing, he's 7 feet over land. So this is where we are starting. And so that's when we get -7, and then over the land is 11. So we have our minimum at -7, and our maximum would be 11, because that's how far over the water we are. And the riverbank edge is right here. So for the start, it says we need to figure out after 2 seconds. So when she starts to swing, he's 7 feet over land. After 2 seconds, he's 11 feet over the water. So if we started here and we go to here, that's 2 seconds. So that's not a full swing though, because remember that if you're thinking about like a Ferris wheel, when we talk about one revolution time around, we're talking about from start and to finish is where you started again. So if we start here and we're swinging, this is not where we started, right? So we have to make a full swing would be all the way back to where we started. So 2 seconds from here to over the water, that means then there is another 2 seconds to get back. So that tells me that the period is 4 seconds. So the maximum is 11 feet over the water, and the minimum is -7 feet, which is on the land. So the amplitude is the maximum minus the minimum divided by 2, which gives us 9. And the midline is the maximum plus the minimum divided by 2, because it's the average, which gives us 2. And so if our period is 4 seconds, that means 4 divided by 4 is 1. So the key points are going by 1 second. And the B value, we know that B times the period equals 2 pi. So the period, or excuse me, so we're solving for B. So B is equal to 2 pi divided by the period. So in this case, 2 pi divided by 4, which is pi over 2. So on my graph, we're going by the key points, which is 1 second. So 1, 2, 3, and 4. And we know that when we started the stopwatch at time 0, we are on the land 7 meters away from the riverbank edge. So we're going to be down here. So then the next place we're going to is going to be our midline, which is at 2. And then we would be at 11, because then we would be over the water 11 feet from the riverbank, and then back to the riverbank, and then back over land. So my graph looks something like this. So we know then on the midline, we're not starting on the midline on the y-axis, we're starting below the midline on the y-axis. So we know this is going to be a cosine graph. So y equals a times the cosine of bx plus d. Since we're starting below, a has to be negative. So for my equation, we get y is equal to, my a is -9 because we're starting below the midline, times the cosine of pi over 2 x, and then plus my midline, which is 2. So that would be my equation for this situation. And of course, then you could use the equation to answer any sorts of questions like, where is her brother Bobby after 10 seconds, etc. So assuming that, of course, we're not slowing down if we were just on the swing, like if it was just perfect motion and there was no friction or anything like that. So we're going to do some practice problems with applications of trig functions as well, but that's all for today.